Hi, this is Tim. Welcome to the Mathly YouTube channel. Today we have a problem from target round 12113. That was a middle school target round. We're looking at question number 6. This question comes to us by request, by the way. Remember, you can always email us with some suggestions for which problems you'd like to see. All right, so here's the deal with this problem, right? We've got this guy who's going to start off running at 5 meters per second. 20 seconds. Then he's going to slow down to 2 meters per second for the next 40 seconds. And he's just going to keep going back and forth. We are calculating his average speed at any point along this entire journey. And then we've got to do stuff with it. But basically, that's what's happening, right? So here's what we want to do. We're running for 20 seconds. Then we're walking for 20 seconds and walking for another 20 seconds, and we're going to repeat the process. So what we really want to do is explore what happens on each 20-second interval, right? So we're going to have a current speed on each interval, and then we're going to be able to measure the average speed in between those intervals, right? So what we've got going on is the current speed for the first 20 seconds is 5 meters per second. And then we're going to have 2 meters per second, 2 meters per second. Then we bump back up to 5 meters per second, 2, 2, 5, 2, 2, 5. That's going to be enough, actually, right? So let's just work with these intervals that we have. What's going to happen is that throughout the first 20 seconds, his speed is always 5 meters per second. So in particular, by the end of that first 20 seconds, his average speed has been 5 meters per second. Now, thing is, once we get to the second 20-second interval, he has spent 20 seconds at 5 meters per second, 20 seconds at 2 meters per second. So the average is going to be halfway in between those. All right, so the average between 5 and 2 is 3.5. And I actually drew this a little bit lower than the 5, because the thing is, we're going to be dropping, right? So we started off at 5 meters per second. We're going to be dropping then until the end of the first minute. And then once we get 5 meters per second again, we're going to be increasing our average. We're going to be dropping again for the next 40 seconds, increasing, all right? So basically every time, so Arthur starts off at 5 meters per second for 20 seconds. Every time he drops down to 2 meters per second, his running average is going to drop also. And then when his speed increases to 5 meters per second, that's going to raise his average throughout the whole time he's going at 5 meters per second. Okay, so anyway, what happens at the end of the first minute? So we've got 20 seconds at 5, 20 seconds at 2, 20 seconds at 2. The average of those three numbers, 5 plus 2 plus 2 is 9, and we've got 3 intervals. So that's going to be 9 divided by 3, which is 3 meters per second. All right, next up, at the next interval, after the second time that Arthur is doing his 5 meters per second, we've had 4 intervals, 2 of which were at 5, 2 of which were at 2. So the average there is going to be 3.5. For our first 5 intervals, the sum is 16. Right, so we've got a 5 plus 2 plus 2, that's 9, plus 5 plus 2, that's another 7. Total of 16, and we've got 5 intervals. 16 divided by 5, that's going to bring us down to 3.2. So in other words, this is after 100 seconds. His average speed is down to 3.2. Okay, then after the 6th interval, we see that the overall average speed is going to have dropped back to 3. And in fact, I think you can probably see at this point that after each minute, the average speed for the previous minute was 3 meters per second. And the average speed for all the other minutes was also 3 meters per second. So every time we finish a minute, we are back down to this baseline. This lowest possible average speed is going to be 3. But what I want you to notice is that during our first time that Arthur was traveling 5 meters per second, we were averaging 5 meters per second. By the time he finished his second stint at 5 meters per second, we're only up to an average speed of 3.5. Right, so at the start of this 5 meter per second stint, we were at our baseline, our lowest possible speed that we get to at the end of every minute. We only managed to raise that average up to 3.5 in these next 20 seconds. So we weren't quite as high as we were before. Well, let's see what happens after the third time that we're at 5 meters per second. So what have we got so far? 1, 2, 3, 4, 5, 6, 7 intervals. I've got 3 5s for 15. I've got 4 2s for 8. 15 plus 8 is 23, and we're dividing that by 7. So I'm just going to write it as a fraction here. This is 23 over 7. When we get to the next one, after this next 20 seconds of going 2 meters per second, the total of all these 8 numbers is going to be 25. So it's 25 over 8. And then we're back down to 3. Then we add this 5 again. How many intervals have we done now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's a nice denominator to work with. How many 5s? 1, 2, 3, 4 of these 5s. That's a total of 20. And I've got 1, 2, 3, 4, 5, 6 2s. That is a total of 12. So 20 plus 12 is 32. And we had 10 intervals. 32 divided by 10 is 3.2. Okay, so that is going to occur after this 5. At this point, we should probably take a look at what's happening, what they're asking us to do, right? So we have a big picture of what's going on, right? This guy's going fast and then slow and then fast and then slow, but we're measuring the average. Right, so the average is always going to be between the fast and the slow. But because he spends a third of his time at 5 meters per second anyway, the average is never going to drop below 3. Because we start each minute at 5 meters per second, that gives us a chance to rise a little bit above the 3 each time. But you'll notice that after each 5 meter per second run, this average ends up being a little bit less than it was before. Right, because those 5s are not as big of a deal relative to all the other stuff that's going on. Okay, so if we were to graph this, right, we're going from 5 down to 3, and then up to 3.5, down to 3, and then up to 23 over 7. That's a little bit over 3, down to 3, and then up to 3.2. Then, of course, we'll end up down to 3 again. So all these troughs are 3 meters per second. But what's happening is that these swings are not going to end up being as wide. That's where the question comes in. What's the smallest number of seconds it passes until, so from the start of your journey until, let's see what we're saying, the difference between the greatest recording that we're ever going to have from here on out and the least recording from here on out is within 0.2 meters per second. I want the difference to be within 0.2 meters per second. I know that the least that we're ever going to have, and we're going to hit this at the end of every minute, is 3 meters per second. If I want the difference to be within 0.2, that means that the greatest current or future recording is going to need to be 0.2 meters per second above this 3. So I need to figure out when is the first time that we know for sure we will never be above 3.2 again. All right, so there's going to be some point down here that we are never going to be above 3.2 again. Well, if we ended this, what is it, 1, 2, third minute, we ended this third minute at an average speed of 3, and the highest we get in the next minute goes up to 3.2. Then at the end of that minute, we're going to be back down to 3. Next minute, we're not even going to get up to 3.2. And so basically this last time that we hit a 3.2 before the end of the third minute, this is when we're going to have that difference being 0.2, right? So anytime before, so I'm looking at this intersection point right here. Anytime before that, you will always be able to say, oh yeah, at some point in the future or now, I'm going to have more than 0.2 meters per second of a gap between the highest and lowest readings that I'll ever get from here on out. By the time I pass this intersection point, there's never a point on this line that is outside the interval of 3 to 3.2. So we're always going to be within 0.2 meters per second. Right, our greatest and lowest from then on out is always within 0.2. So we just need to find somewhere in this interval, right, and that occurred during the 3rd minute, okay? After 1 minute, after 2 minutes, and then after 3 minutes, we're down here. Somewhere in this 3rd minute, we're going to hit 3.2 meters per second as our running average. And at that point, we'll never get back above 3.2 for our running average. Okay, so we just need to figure out where that is. So at the end of the 2nd minute, right, we were down here. At the end of 140 seconds, we were at this peak, which is 23/7. And 23/7, if you work it out, it's about 3.2, right? So 3.28, I should say, because that's what 3 2/7. So it's about 3.28. After 160 seconds, we're at 25/8, which is 3.125. Right? So that's going to be somewhere in here. And so we know somewhere between 140 seconds, right? After 7 intervals, that's 140 seconds. Somewhere between 140 seconds and the end of our 8th interval, which is 160 seconds, somewhere between 140 and 160, we're going to hit a running average of 3.2. That's what we need to figure out at this point. So we know that we are somewhere between 140 and 160 seconds. Now, what happens in this particular interval? Let's measure what's gone on so far and how far we've traveled. Okay, so first off, we know that we've traveled a total of 60 seconds at these 5 meters per second, right? That's 3 complete intervals at 5 meters per second. We also know that we have traveled 80 seconds, 20, 40, 60, and 80, plus however much we've used up from this next interval, right? So we've got 80 plus X seconds at 2 meters per second. Now, if we want to find the overall average up to this point, right, we're basically measuring X seconds forward from 140. We're going to end up solving for X and we'll have our answer there, right? So we want to know what's going on X seconds after 140. Well, first off, the average speed is going to be distance divided by time. Total distance is going to be 60 seconds times 5 meters per second. That's 300 meters, of course, plus 80 plus X seconds at 2 meters per second. That gives us 160 plus 2X meters. That's the meters. We have to divide that by the total number of seconds, which is 60 plus 80 plus X, or 140 plus X. So this is what the equation looks like at this point. And if we wanted to simplify this out, then it's going to look something like this. So I already mentioned that we had 300 meters at 5 meters per second. Got 160 plus 2X, so that becomes 460 plus 2X. That's our numerator. If I multiply everything across for the denominator, we're going to get 3.2 times 140 plus 3.2x. Remember, 3.2 is the average that we're looking for, right? So the left-hand side of this fraction was our calculation of the average, and the right-hand side is, oh yeah, we wanted it to be 3.2. Let's just do some calculations here. 3.2 times 140 is the same thing as 32 times 14. So you can go ahead and calculate it that way if you want. 30 times 14 is going to be 420. Another 2 times 14 is another 28. So that's 448. What that leaves us with is just a 12 for our constant if we subtract the 448 from both sides. We're also going to subtract 2x from both sides, leaving us with 3.2x minus 2x, or 1.2x. 12 equals 1.2x, and it's pretty easy to see then that x equals 10. Now, what does that tell us about the overall answer? Well, if x equals 10, remember the whole point was we were traveling 80 plus x seconds. at 2 meters per second. So that's 90 seconds plus 60 seconds at 5 meters per second. 90 plus 60 is 150 seconds overall. The other way you can look at that is 140 plus X was our total number of seconds. You can also say, oh, I started at 140, I added X seconds, which is 10, and that gives me a final of 150. That's how it's done. Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.